So we're going to do our project a little eccentrically. We made a neat little poster. We're not going to show it because we're going to turn the poster into her. We're going to actually kind of demonstrate to you our project. She's going to read it and explain it, and I'm going to try and demonstrate what's going on. So, wish us luck. So, alright. I believe what she's going to do is I wrote a card that's all technical and overly wordy and like way too stupid for this class. So she dumbed it down and made it so it actually makes sense. So, luckily I have a partner that's talented enough to do that. So, let's start it.
Okay, so we have a huge source of energy that is supplied to our plants by electromagnetic waves from the sun. So basically the sun sends energy down to the plants and they're absorbed there.
See, when you talk about energy, almost all of our energy comes from the sun. And when we're going to be talking about oil, it starts when the sun shines down and you have plants, organic material, things like that, start absorbing it, which was actually explained in one of the presentations the other day.
So in various periods of our history, like the Carboniferous phase, there was large amounts of organic material floating in the ocean. So basically it was just a bunch of plants and algae floating in our oceans.
Okay, so we got organic material here, and it has to be floating in an ocean, so let's make this an ocean. I brought a can of water. He was so nice to hold the water. So let's put some water on this organic material. Little mini ocean in the middle of a chemistry class. Ain't that awesome? All right. So now we have organic material in an ocean.
So then this material then dies, sinks to the bottom, and over a long period of time is covered by layers of sediment, creating a lot of pressure, which means all this stuff dies and falls to the bottom of the ocean and gets covered up by a bunch of dirt.
Okay, here's what happens. When it dies, it falls to the bottom of the ocean. It makes an anaerobic environment. What that means is it cannot breathe oxygen. It gets covered up by a whole bunch of junk. It's just like a counter. When you get dust built up on it, you can see dust on your counter. Things have sediment built up on it. That sediment creates weight, which creates a pressure, which pushes in on the volume, which, as we learned in chapter with our gas laws, increases the temperature. When you increase temperature, it's a catalyst for chemical change.
So basically the dirt that builds up on it cuts off all the oxygen, making it possible to become petroleum.
So it can't breathe, and it starts changing because the pressure, the dirt, the anaerobic environment, which is no oxygen, gave it what it needed because this stuff wanted to become oil in the first place.
Okay, so after all the chemical transformations, petroleum begins to migrate through the surrounding area due to the movement of Earth's crust, and some of it escapes to the surface.
Okay. Our Earth has plates, tectonic plates. And all this stuff is on top of these tectonic plates. And these plates start to move. And that's what makes earthquakes and fault lines. But as that happens, that sediment and all those layers that built up starts moving around it. Well, what do you think's heavier? A big old huge rock on top of something? Or natural gas and oil and all your other biodiesels? They're lighter. So when we learn about density, what happens to the least dense material? It comes upwards. So what happens is you get some of this stuff, it starts to come up and comes out through seepage. And this is what you got going on in California right now, where you got a lot of methane coming out of the ground. We're losing a lot of methane through our service to California.
Okay, so however a large amount will encounter a rock layer where it will be unable to pass through, which means it's just going to get trapped down there.
Alright. So, as you see, one of our layers of sediment was a sweater. If I'm walking outside in the rain, my shirt's going to get wet underneath the sweater. Trust me, I've done it. We also had a jacket, but we also had a layer of sediment that was a plastic bag. So, as it's coming up, this plastic bag is not going to allow the oil or the petroleum, the biodiesel, to actually get through it. So it gets trapped inside of it. And whatever got around it, that was what the seepage was. It's coming up through the ground. Okay? And then it builds in this little area right here underneath this bag.
Which is called a reservoir. wire, and this is where oil companies will dig to get petroleum.
Well, if you work for British Petroleum, ExxonMobil, any of the big oil companies, as a petroleum engineer, your job is to find where this is at. And they want to get to it real bad.
So from the time the organic material dies and becomes petroleum, and then it's refined, it takes at least 1,000,000 years for all of this to happen.
So, if I'm an oil company and I want to get through this, I'm going to create a big old drill, and I can punch a hole through it. Now, none of you guys might not remember, there was a show called Texas Hillbillies or something like that. The guy shot a gun, a bullet hit oil Texas tea, started shooting out. I guess that would kind of work if you have a real high pressure, but it's not that easy. If it was that easy, gas would be like 15 cents a gallon. So what companies do is they drill a hole right here, and they drill a hole right here, and they shoot in pressure through water, anything you want, and then they'll put a poke hole right here, and that pressure will push the oil up and out through it. And once the oil comes up, the organic material becomes energy. But that energy is not pure because it has sediment built up on